Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Matrix Labs, the video number 45. We have been discussing in the previous video the following. We have still working on the testum report findings concerning our primary domain controller. We have seen a lot of recommendations or tests done on the primary domain controller. Some of them are related to the security of the domain controller and the Active Directory. Some of them are related to the disk space of the C partition of the primary domain controller, the free space actually. We should have at least 20% free space on our C partition on our primary domain controller to guarantee a smooth performance of our operating system, and this will affect the performance of the Active Directory itself. So we can see the testum report is running a lot of tests that are very useful. Some of them are taken from the DCDiag and rep admin tools. Some of these tests depend on the DCDiag and rep admin tool, and some of them are custom tests, okay, that are created based on famous discussions concerning the Active Directory health issue. So this guy, the one that made the test report, has seen a lot of articles concerning the Active Directory health and performance, and then he made these 644 tests based on what he has read from and seen from a lot of IT professionals concerning the Active Directory health issue. Anyway, we will continue from this point, which is NTDS parameters. This is a very important issue. These are the parameters that are related to the Active Directory database and the replication of the Active Directory database. So he's checking the NTDS parameters, which can be accessed from this registry key. He's checking all of these parameters. He will see if there is any wrong parameters. He will focus on, or he will point to these wrong registry keys, and he will point them in the report. And he's checking that the domain controller should be writable. Then he is concerning, or he is focusing on this domain controller should not be a read-only domain controller. Okay, so he's focusing now on that this domain controller should be a primary or additional, but not a read-only domain controller. I think this is related to the setting of the read-only domain controller. There is different setting of the read-only domain controller, different than the normal domain controllers. Anyway, so we can see this is the registry key, and I have asked Perplexity to list all of the registry keys in this path and see what are these parameters. So if we go and see the registry key here is explain this registry key and its subkeys. So here I'm telling him to explain the NTDS. Let me go and show you. Here I'm telling him to explain this NTDS parameters key. I have given him all of the registry keys, okay, and the subkeys, and I'm telling him to explain them one by one. We can see some of them are very obvious. Database backup path, database log path. So we will see each one of these registry keys explained, so we can know why it is very important to check all of these registry keys to make sure our Active Directory is working smoothly. So let's see the answer of Perplexity.
The registry key HKY underscore local underscore machine backslash system backslash
Pro.
Explain this registry key and its subkeys HKY machine.
Just wait for a moment, guys. Actually, sorry. Let's go and read this from the beginning. Here you go. Now we can get all of the key again and go further down. Okay, now we can go further, and then here you go. Let's read that loudly.
The registry key HKY underscore local underscore machine backslash system backslash current control set backslash services backslash NTDS backslash parameters contains several important parameters related to the configuration and operation of Active Directory Domain Services, ADDS. Below is an explanation of the specific parameters you mentioned. Explanation of NTDS parameters. Configuration in C. Description. This parameter holds the distinguished name, DN, of the configuration naming context, in C, for the Active Directory forest. It defines the structure and configuration data for the entire forest. Database backup path. Description. This string value specifies the path where the Active Directory database backups are stored. Proper configuration of this path is essential for disaster recovery. Database log files path. Description. This parameter indicates the location of the transaction log files associated with the Active Directory database. These log files are crucial for recovery operations and maintaining data integrity. Database logging/recovery. Description. This setting determines how the database logs are managed and whether they are used for recovery purposes. It can affect the performance and reliability of the Active Directory service. DS drive mappings. Description. This parameter may define mappings for drives used by the directory services. It helps in organizing and accessing resources efficiently. DSA database epoch. Description. This value represents the epoch of the Directory Service Agent, DSA, database. It is used to manage replication and track changes across domain controllers. DSA database file. Description. This string value specifies the path to the primary Active Directory database file, typically named ntds.dit. This file contains all the directory objects and their attributes. DSA working directory. Description. This parameter specifies the working directory for the DSA, where temporary files and other operational data are stored during normal operations. DSA options. Description. This DWORD value contains flags that configure various options for the Directory Service Agent, such as enabling or disabling specific features or behaviors. Global Catalog Promotion Complete. Description. This DWORD value indicates whether the domain controller has been successfully promoted to a global catalog server. It is important for multi-domain environments to ensure proper directory access. Hierarchy Table Recalculation Interval, minutes. Description. This parameter specifies the interval at which the hierarchy table is recalculated. This can affect performance and the accuracy of directory searches. Is clone. Description. This DWORD value indicates whether the domain controller is a clone of another DC. Cloning is used for rapid deployment of domain controllers and requires specific configurations. LDAP server integrity. Description. This DWORD value controls the integrity requirements for LDAP connections. It can enforce signing or sealing of LDAP communications to enhance security. Machine DN name. Description. This string value contains the distinguished name of the machine object in Active Directory. It uniquely identifies the domain controller within the directory. Root domain. Description. This parameter specifies the distinguished name of the root domain in the Active Directory forest. It is essential for the overall structure and organization of the directory. Schema version. Description. This DWORD value indicates the version of the schema that the domain controller is using. It is crucial for compatibility with various Active Directory features and updates. Service DLL. Description. This string value specifies the path to the Dynamic Link Library, DLL, that contains the service code for the directory service. It is essential for the operation of the Active Directory service. Strict replication consistency. Description. This DWORD value determines whether strict replication consistency is enforced across domain controllers. Enabling this option helps maintain data integrity. System schema version. Description. This DWORD value indicates the version of the system schema that is currently in use. It is important for ensuring that all domain controllers in the forest are compatible and can replicate correctly. Conclusion. These parameters play a vital role in the configuration and operation of Active Directory, affecting everything from database management to replication and security. Proper understanding and management of these settings are crucial for maintaining a healthy and secure Active Directory environment. Share. Rewrite.
So as we can see here, these settings are related to the database of the Active Directory and the replication and the security of the Active Directory. So we see a lot of useful registry keys that play an important role to secure the Active Directory and to enhance the performance of the replication of the Active Directory database. So we can see all of these explanations are in a little bit technical terms. So if we need to simplify these registry keys in a simple, or explain it in layman terms, or in a normal or in a simple way, we can ask it to explain it again, but to be simpler so we can comprehend or we can understand. Okay, so let's read the simplified version of simplified explanation version of these registry keys. If we go there and ask it to explain it but in simple terms, so let's do that.
Here's a simplified explanation of the NTDS parameters found in the registry key HKEY _local machine \system \pro.
Okay, let's read it again.
Here's a simplified explanation of the NTDS parameters found in the registry key HKEY _local machine \system \current control set \services \NTDS \parameters. Simplified explanation of NTDS parameters. Configuration in C. What it is. This is like the blueprint for your Active Directory setup. It helps organize how everything is structured within your network. Database backup path. What it is. This tells the system where to save backups of your Active Directory data. Think of it as a safety net in case something goes wrong. Database log files path. What it is. This is the location where the system keeps logs of changes made to the Active Directory. These logs help recover data if something goes wrong. Database logging/recovery. What it is. This setting decides how the system handles its logs and whether they can be used to restore data. It's important for keeping everything running smoothly. DS drive mappings. What it is. This helps the system know where to find certain drives or resources it needs to access, making it easier to manage everything. DSA database epoch. What it is. This is a version number for the database that helps keep track of changes and updates across different servers in your network. DSA database file. What it is. This is the main file where all your Active Directory information is stored. It's like the main book that contains all the records. DSA working directory. What it is. This is a temporary storage area where the system keeps files it needs while it's working. It's like a workspace for the Active Directory service. DSA options. What it is. These are settings that allow you to customize how the Active Directory service behaves, similar to preferences in an app. Global catalog promotion complete. What it is. This indicates whether a server has been set up to act as a global catalog, which helps speed up searches across the network. Hierarchy table recalculation interval, minutes. What it is. This setting determines how often the system updates its organizational structure. Regular updates help keep everything accurate. Is clone. What it is. This tells the system if the server is a copy or clone of another server. Cloning helps quickly set up new servers. LDAP server integrity. What it is. This setting controls how secure the connections are when accessing directory information. It helps protect against unauthorized access. Machine DN name. What it is. This is the unique name that identifies your server in the Active Directory. It's like a name tag for the server. Root domain. What it is. This is the main domain name in your Active Directory setup. It's like the parent organization that holds everything together. Schema version. What it is. This indicates the version of the rules and structures used in Active Directory. It's important for making sure everything works together correctly. Service DLL. What it is. This is a file that contains the code needed for the Active Directory service to run. It's like the engine that keeps everything moving. Strict replication consistency. What it is. This setting ensures that all servers in the network have the same data. It helps prevent errors and keeps information reliable. System schema version. What it is. Similar to the schema version, this indicates the version of the overall system rules being used. It's essential for compatibility across servers. Conclusion. These parameters help manage and maintain the Active Directory system, ensuring it runs smoothly and securely. Understanding these settings can help keep your network organized and functioning properly.
So as you can see here, this is very simple explanation. Now we can know all of these registry keys and their functions, and actually if you need to see a screenshot of how this registry keys look like, if we go to this screenshot where it is for let me get it. It is NTDS. Here you go, this is it. So as we can see, here is the NTDS parameters. As we can see, all of these are explained by a Perplexity. One of the most interesting registry keys I found is clone. So there is an option to clone the domain controller, okay? And actually it's very useful if you are using a virtualized domain controller, especially if it is a Hyper-V virtual machine. So there is a way that you can clone a Hyper-V virtual machine acting as a domain controller. It can be done in simple steps, and you have a clone of your primary domain controller. I think it will act, the clone will act as additional in a couple of minutes. So this is a very useful option. I didn't actually do this option before, but interesting. I asked the Perplexity how this method is done, how we can clone a domain controller, and what is more effective, to make a clone or to make a virtual machine from scratch and install operating system and then install Active Directory domain services and promote the server to be a domain controller. Let's see the answer of Perplexity concerning this issue. Okay, so here, first of all, before going and seeing the answer here, I asked Claude to explain the same registry keys here in simple terms, but I think the answer of Perplexity is very simple here. So here we can see anyway, I think we don't need to see the answer, so let's continue. Here we can see this is how we can clone a domain controller, especially if it is a virtual machine on an Hyper-V platform. Okay, so let's see the answer, and then I ask it another question. Can we do that with a virtual machine that is on VMware platform, not on Hyper-V platform? So let's see the answer and see how we can clone and when we should clone. Okay, so let's see that. Okay, here you go, continue reading, and then
Cloning a domain controller, DC, is a process of creating an exact copy of a virtualized domain controller. This feature was introduced in Windows Server 2012 and allows for quick deployment of new DCs without the need for manual promotion. Here's how cloning a domain controller works. Preparing the source DC for cloning. Log into the source DC as a domain admin or enterprise admin. Add the source DC to the clonable domain controller's security group in Active Directory users and computers. Run the getaddc cloning excluded application list PowerShell complete to check for any incompatible applications on the DC. If any are found, remove or exclude them. Creating the clone configuration file. Run the new add clone config file PowerShell complete to generate a configuration file for the clone DC. Specify the IP address, DNS resolver, subnet mask, computer name, default gateway, and site name for the clone DC in the configuration file. Exporting and importing the virtual machine. Shut down the source DC to prepare for cloning. Export the source DC virtual machine using Hyper-V Manager. Import the exported VM and select Copy the virtual machine. Create a new unique ID option. Finalizing the cloning process. Start the clone DC virtual machine. The clone DC will go through several stages to prepare Active Directory, including obtaining a new machine SID and computer account. The clone DC will replicate from the source DC to obtain the necessary directory data. During the cloning process, the VM generation ID is changed, which helps prevent the clone DC from being considered an untrusted DC. The clone DC will have a new machine identity, including a new name, SID, and computer account. It's important to note that cloning is only supported for virtualized domain controllers and not for other server roles like DHCP or certificate services. Additionally, the source DC must be running and accessible during the cloning process for replication to occur successfully. By following these steps, you can quickly create a clone of a domain controller, which can be useful for setting up test environments or quickly restoring a failed DC in a disaster recovery scenario.
So this is one good answer. Here, can this be done on VMware Workstation Pro or vSphere? If yes, give steps. So here we need to know the steps for doing the same process, cloning a domain controller, but on another hypervisor platform, which is VMware or vSphere. Let's see the answer just to make sure we have all the steps. And by the way, one good thing of Perplexity that it can give you the sources of the information he is displaying and also videos and images. So he can give URL concerning the source of the data that he is displaying in front of you on the screen, and then he can give you screenshots and videos concerning your answer or concerning the answer he is displaying. So let's first read this thing here. Sorry. So again, we can do that in reverse order. Okay. So here we go, and then tell him to read it.
Yes, you can clone a domain controller using VMware Workstation Pro or vSphere. Below are the steps to perform the cloning process specifically for VMware vSphere, as it is more commonly used in enterprise environments. The process is similar in VMware Workstation, but may vary slightly based on the interface. Steps to clone a domain controller on VMware vSphere. 1. Prepare the source domain controller. Log in to the domain controller. Use a domain admin or enterprise admin account. Add to clonable domain controllers group. Open PowerShell and run the following command to add the DC to the clonable domain controllers group. PowerShell. Add AD group member identity, clonable domain controllers, members, CN equals your DC name, OU equals domain controllers, DC equals your domain, DC equals TLD. Check for non-clonable applications. Run the following command to identify any applications that may block cloning. PowerShell. getaddc cloning excluded application list. If any applications are listed, remove or address them as necessary. Create clone configuration file. Generate a configuration file for the clone by running PowerShell. New add clone config file static, IPv4 address, 192.168.x.x, IPv4 DNS resolver, 192.168.x.y, IPv4 subnet mask, 255.255.255.0, clone computer name, new DC name, IPv4 default gateway, 192.168.x.z, site name, default first site name. Replace the IP addresses and names with your desired values. 2. Clone the domain controller. Shut down the source domain controller. Ensure the source DC is powered off before proceeding. Open VMware vSphere. Log into your vSphere or vSphere web client. Locate the source DC. Find the virtual machine, VM, representing the source DC in the inventory. Clone the VM. Right-click the VM and select Clone. Follow the prompts. Select a name and folder. Enter a unique name for the clone DC. Select a compute resource. Choose the host or cluster. Select storage. Choose the data store for the VM files. Select deploy options. Do not select any additional customization options. Review the settings and click Finish. 3. Finalize the cloning process. Start the clone domain controller. After the cloning operation completes, locate the new clone DC in the inventory and power it on. Complete the initialization. The clone DC will go through a series of initialization steps. It may restart several times as it configures itself. Verify the clone DC. Log in to the clone DC using a domain admin account. Check that the new DC appears in the domain controller's organizational unit, OU, and under Sites and Services. Important considerations. Ensure that the source DC is not the only DC in the domain to avoid issues during the cloning process. Clone DCs should not be connected to the production network until they have been properly configured to avoid conflicts. Always verify that the primary domain controller emulator, PDC, is reachable during the cloning process. By following these steps, you can successfully clone a domain controller in a VMware environment, facilitating rapid deployment and recovery in your network.
So I see here the second answer is more precise. So here he is suggesting that we are cloning an additional domain controller, okay, not the primary. So the primary will be the source of the cloning process. So we are creating here, this process is we are cloning an additional domain controller. Okay, so I think this is here the process. We are cloning an additional domain controller, not the primary domain controller, because it should be on during the process of the cloning. And this is a good option, but the question that arises, which is better, cloning DCs or creating new one from scratch? So this is one good question to answer. When should we clone a primary domain? When should we clone a domain controller? But I think here the cloning should be for an additional domain controller too. So for example, if you have a primary domain controller and you have, for example, two additional domain controllers, one of them is down, okay, so you need to replace it with another one. So you can clone the working domain controller or the additional working domain controller and make another one in very, very easy step. So here the question, when should we clone and when should we create from scratch? Let's see the answer and see the advantages and disadvantages of each process. So let's go there.
When deciding between cloning a domain controller, DC, and creating a new one from scratch, it's essential to consider the advantages and disadvantages of each approach. Here's a comparison based on the information gathered. Cloning a domain controller. Advantages. Speed and efficiency. Cloning allows for rapid deployment of additional domain controllers. This is particularly useful in scenarios like disaster recovery or when scaling up to meet increased capacity needs. Cloning can significantly reduce the time required to set up a new DC compared to manual configuration. 1. Explain this registry key and its sub.
Sorry guys, let's go to the other one. So I can read it here. Consistency. Cloning ensures that new DCs have the same configuration setting and application as the original. This can help maintain consistency across your network, which is crucial for operation efficiency. Testing environments. Cloning is beneficial for creating test environments where you can deploy and test new features before rolling them out in production. This allows for safe experimentation without affecting the live environment. Resource optimization. In virtualized environments, cloning can optimize resource usage by quickly provisioning new DCs without needing extensive manual setup. These advantages: security risk. Cloning a DC can inadvertently duplicate sensitive information such as security accounts or permissions. This can pose security risk if not managed properly, especially if the clone DC is used in a different organization. So this is one thing, not to clone a DC from a different organization or a different forest. I think here is referring to that. We can go to the reference here. For example, one article saying is cloning Active Directory good or bad? So you can read the article. Dependency on the source DC. The cloning process relies on the source DC being online during the cloning operation, which can be a limitation in certain scenarios. Okay, application compatibility. Not all applications are compatible with cloning. Some may require specific configuration or may not function correctly in a cloned environment, necessitating additional testing and validation. So sometimes the clone can be a headache if there is some application compatibility issues. Creating a new domain control from scratch. Fresh installation. Advantages: a fresh installation. Setting up new DC from scratch allows for clean slate. You can configure it according to the latest requirements and the best practices without carrying over any legacy configuration or potential issues from the original DC. So this is one very good point and advantage. Security control. By starting fresh, you can ensure that only the necessary accounts, permissions, and configuration are included, reducing the risk of security vulnerabilities that might arise from the cloning. Of course, if the other cloned DC doesn't have some security patches or have some security issues. Flexibility. Creating a new DC allows for more flexibility in terms of design and architecture. You may implement new policies or structures that better fit the current needs of your organization. Advantages: time consuming. Of course, setting up a new DC from scratch can be time consuming, requiring manual configuration, offsetting, policies, and replication setting. This can delay deployment, especially in urgent scenarios, disaster recovery, for example. Potential for inconsistency. The risk of inconsistency if the new DC is not configured identically to the existing DCs. This can lead to issues with the replication overall network functionality. Resource intensive. Creating a new DC may require more resources in terms of planning, configuration, and testing, which may not be idle in fast-paced environments. Okay, you need to deploy a DC very quickly. So you need the cloning is the best choice here. The choice between cloning a domain controller and creating a new one from scratch largely depend upon the specific needs and circumstances of your organization. Cloning is beneficial for rapid deployment and consistency, particularly in virtual environments, while creating a new DC offers a fresh start with enhanced security and flexibility. Evaluating the security, implementations, application compatibility, and operational requirements will help determine the best approach for the situation. The security, the application compatibility, the operational requirements. These are the 3 points you need to consider when choosing between cloning or creating from scratch. So, all of these, not to go further, we were talking about the NTDS parameters, okay, of the Active Directory. The test or the test to report is checking the NTDS parameters of the Active Directory, or these settings are related to the Active Directory database, the replication, the security of the Active Directory. So this is very, very important registry keys we need to check. He's checking them and he's making sure that you have a domain controller that is writable, or it's not a read-only domain controller. Okay, so if we go further to the next point, which is group policy sysvol verification, here he is checking if the group policy count, okay, in the sysvol folder is the same as the count when accessing the group policy management console. So you need to know if the group policy count is the same in the group policy management console and in the sysvol folder. If there is any differences, you will see some group policies are not applied, or some group policies not, or some issues concerning the group policy. So this is the group policy sysvol verification. Okay, so here is the registry key, or not, this is the script to do that. And we can go to the next one, or the next thing, which is LAN manager setting. Okay, we'll talk about this LAN manager setting. This is very, very important protocol used for authentication of users. Okay, this is an older, or this is an old protocol that was used before Kerberos. So this protocol have now a version called NT LM version 2. So there is an updated version of this protocol. It is not used extensively as the Kerberos, because the Kerberos is more robust and more secure than the NTLM version 2. Why it is still used for now? Because some applications or old applications use the NTLM version 2 protocol for authentication. Okay, so we are using this protocol in some circumstances. We will talk about the NTLM, or we talk about the LAN manager and its versions, and the Kerberos, and some similarities between the two protocols, when we can use this one and when we can use the other one, and a lot of things actually. So let's see what the tests do. This test is checking the NTLM version 2 setting. He's checking all of the setting for this protocol to secure the access to the Active Directory. Okay, so this is because this protocol is used for authentication of users to access the domain. So we need to secure the access of the user to the domain by securing the authentication process. So we are securing the authentication process by securing the NTLM version 2 protocol. Okay, so we'll talk about each of these settings for this protocol. Some of them are not set correctly, we need to change them. And for example, here he's talking about two things. He's talking about the LAN manager level and talking about LSA protection credentials. We will talk about these two in specific. But before that, I need to go to the video and see our work. We will see if there is anything we will do practically before discussing theoretically the third test, or the test of the LAN manager. Let's see if we have anything here to do. So here I'm putting this script to get the NTDS parameters. Here is saying that I cannot recognize this command, so we can go and check the parameters manually by opening the registry or regedit and check the parameters. And here I'm asking ChatGPT 4o to give me a script to list all of these registry keys concerning the NTDS. Okay, so here will give me a script to list all of the registry keys under this or under this location. So now I can copy this one, and I can go and see or open my PowerShell ICE and then put the script. But before that, we can make a clear for the screen, and then we can remove this old script and then put that and then run the script. Now we can see these are all the parameters of the NTDS. You can go further because I don't need to here I'm asking it to explain the registry keys, but anyway we don't need all of these. Here I'm asking Perplexity to do that. We have seen this, you have seen all of these, and now we can go to the next test, which is group policy sysvol verification. Here this is the script that will check the group policy count in both the group policy management console and the sysvol folder. So you can go now and run this command. Just we need to put the domain and the domain controller. And then we need to put the domain and the domain controller. And then press enter. We can see if there's no result appearing, then we are good to go. Now we can see that we have successfully passed these tests. Now we will stop at this test and see what is the LAN manager, okay, what is this protocol and what it is used for. Okay, and one thing also here we need to make sure we are talking about the NTLM or the LAN manager protocol that is used for authentication of users, and you are talking about one security point also in the domain. We need to close an option called everyone include anonymous. This is a feature that we need to disable in our domain. What is this? This setting prevents an unauthorized user for anonymously listing account names and shared resources and use the information to attempt to guess passwords and perform social engineering attacks. So there is a way. If one user is outside the domain, okay, he can gain access or he can list all of the accounts in your domain and the resources used in your domain. He can list them, so by listing them he can hack them later. This is if a user is outside the domain. So how this is done? Because there is an option in our domain saying that any user that is outside our domain or an anonymous user, he will take the permissions of everyone. Okay, this is a group in the Active Directory, okay, that have certain permissions. So these permissions will allow the members in this group to list the accounts and the resources used in your domain. So what we need to do, we need to close or disable this option. So if any user outside our domain, okay, or an anonymous user should not take the permissions of the everyone group, because if he takes these permissions, he can hack our domain. So we need to disable this. Everyone includes anonymous. This is was said, or was a recommendation by the Department of Defense of the United States. This setting helps define the permissions that anonymous users have. If the setting is enabled, the anonymous user have the same rights and permissions as the built-in everyone group. Anonymous users should not have these permissions or rights. Okay, this can be done using a registry key, or we can disable this feature from our security options. Okay, on the Windows setting of the computer configuration, we can do this by let everyone permissions apply to anonymous user to disable. So this test is talking about disabling this feature, and it is talking about securing the NTLM version 2 protocol, which is used for authentication of users in certain situations. And he is talking about the setting for this protocol. We need to have certain settings for this protocol to secure it more. Okay, so first let's see what is LAN manager. We need to know what is the LAN manager. Okay, what is used for, what is the similarities between it and the Kerberos. Let's see an answer. Here we have what is LAN manager exactly. Here is, let me first go and close the voice recording. If we go to that, what is the LAN manager exactly? We can go and ask Perplexity. Okay, here is the answer, but first let me see how much time we are having here. We have 46 minutes, so let's see the answer of uh, Perplexity concerning this answer. Okay, so we can go there. First let's try to have uh, or let me to read it loudly. So now we can read it like that.
LAN Manager. Discontinued network operating system developed by Microsoft and 3Com. More. Development. Developed by Microsoft in collaboration with 3Com Corporation. Operating system family. Part of the OS/2 family, designed to run network services. Key technology. Utilize server message block, SMB, protocol over NetBIOS frames or Xerox Network Systems protocols. LAN Manager is a discontinued network operating system, NOS, that was co-developed by Microsoft and 3Com Corporation. It was primarily designed to facilitate local area networking, LAN, and was built to succeed 3Com's earlier 3+ share server software. The first version of LAN Manager was released in 1987, and it was notable for its use of the server message block, SMB, protocol, which is essential for file and printer sharing in Windows environments. Key features and development. Operating system family. LAN Manager was based on the OS/2 operating system and utilized a closed-source model. Protocol support. Initially, LAN Manager supported the SMB protocol over NetBIOS frames, NBF, and later incorporated TCP, IP as a transport protocol, which allowed for broader compatibility and functionality within network environments. Versions. The LAN Manager saw several iterations, with major releases including LAN Manager 1.0, 1987, LAN Manager 2.0, 1990, which introduced TCP, IP support. The final version, LAN Manager 2.2a, 1994. Legacy. LAN Manager's architecture laid the groundwork for subsequent Microsoft products, particularly the Windows and T-Series, which eventually replaced it as the standard for network operating systems. Security concerns. One of the significant drawbacks of LAN Manager was its authentication method, which utilized a weak hashing algorithm known as the LM hash. This method is now considered insecure, as it is vulnerable to various attack methods, including rainbow table attacks. The weaknesses in LAN Manager's authentication led to the development of the new technology LAN Manager, NTLM, protocol, which aimed to provide better security features. Conclusion. While LAN Manager played a crucial role in the evolution of network operating systems, it has been discontinued in favor of more secure and efficient systems. Its legacy persists in modern Windows networking, particularly through the protocols and mechanisms that succeeded it, such as NTLM and Kerberos. As technology has advanced, the reliance on LAN Manager has diminished, with organizations encouraged to adopt more secure alternatives for network authentication and management.
So as we can see here, the LAN manager he is referring to not the old one, it is the NTLM version 2, which is an updated version of the LM. Okay, so we are talking about the NTLM version 2. So here let's see another thing here. what is NTLM version 2? If we ask here, also perplexity, what is NTLM version 2? Here it will give us also an answer. What is NTLM version 2?
NTLM-v2, or NTLAN Manager version 2, is an authentication protocol developed by Microsoft as an enhancement to the original NTLM, NTLAN Manager, protocol. It was introduced with Windows NT 4.0 Service Pack 4 and is designed to provide a more secure method for authenticating users and computers in a Windows-based network environment. Key features of NTLM-v2. Challenge Response Mechanism. NTLM-v2 uses a challenge response authentication method where the server sends a challenge to the client, and the client must respond with a hashed value that proves it knows the password without sending the password itself. Enhanced security. NTLM-v2 improves upon NTLM-v1 by incorporating several security features. Variable Length Client Challenge. Unlike NTLM-v1, which used a fixed length challenge, NTLM-v2 employs a variable length client challenge that includes a timestamp, making it more resistant to replay attacks. HMAC, MD5 hashing. NTLM-v2 uses HMAC, MD5 for hashing, which is a more secure method than the earlier MD4 hashing used in NTLM-v1. Server authentication. NTLM-v2 allows for mutual authentication, meaning that not only does the client authenticate to the server, but the server can also authenticate back to the client, reducing the risk of man-in-the-middle attacks. Compatibility. While NTLM-v2 offers better security, it is still compatible with NTLM-v1, allowing organizations to maintain legacy systems while gradually transitioning to more secure authentication methods. Authentication process. The NTLM-v2 authentication process generally involves the following steps. Negotiate. The client sends a request to the server, including the user's credentials and other configuration information. Challenge. The server generates a random challenge, a nonce, and sends it back to the client. Authenticate. The client responds by encrypting the challenge with a hash of the user's password combined with the challenge and other identifying information. This response is sent back to the server, which verifies it against its stored password hashes. Limitations and vulnerabilities. Despite its improvements over NTLM-v1, NTLM-v2 is not without vulnerabilities. It is still susceptible to certain attacks, such as pass-the-hash attacks. If an attacker gains access to the hashed password, they can authenticate as the user without needing to know the actual password. Brute force attacks. Although NTLM-v2 is stronger than NTLM-v1, it can still be vulnerable to brute force attacks, especially if weak passwords are used. Conclusion. NTLM-v2 is a significant upgrade over its predecessor, NTLM-v1, offering enhanced security features and better protection against various types of attacks. However, organizations are encouraged to transition to more modern authentication protocols, such as Kerberos, which provide even stronger security measures. Despite this, NTLM-v2 remains in use for compatibility with older systems and applications that have not yet migrated to newer authentication methods.
So this is the answer we seek. So NTLM version 2 have the same function as Kerberos for authentication. Okay, so why we use Kerberos? Because it's more secure. Similarities with Kerberos we can see, or here he is talking about the two, or he is comparing the two. We can read also this answer, which is very short actually. And the next question is when Kerberos is used and when NTLM version 2 is used. This is a very important question, but first let's see the similarities between the two protocols. Okay, also this answer could be one very important thing. Okay, let's read it loudly.
NTLM-v2 and Kerberos are both authentication protocols used primarily in Windows environments, but they have distinct features and functionalities. Here are the key similarities between the two. Similarities between NTLM-v2 and Kerberos. Purpose. Both NTLM-v2 and Kerberos are designed to authenticate users and computers in a network environment, ensuring that only authorized entities can access network resources. Integration in Windows. Both protocols are integrated into Microsoft Windows operating systems and can be used for authentication within Active Directory environments. Support for mutual authentication. While Kerberos inherently supports mutual authentication, NTLMv2 can also provide a form of mutual authentication, albeit in a less robust manner. This means that both protocols can verify the identities of both the client and the server involved in the authentication process. Use in network environments. Both NTLMv2 and Kerberos are utilized in network environments to facilitate secure communication and resource access, particularly in enterprise settings. Challenge response mechanism. Both protocols employ a challenge response mechanism to authenticate users, although they implement this process differently. NTLMv2 uses a challenge issued by the server, while Kerberos uses tickets issued by a key distribution center, KDC. Compatibility. NTLMv2 can serve as a fallback option when Kerberos authentication fails, allowing for continued access to network resources even if the preferred method is unavailable. Conclusion. While NTLMv2 and Kerberos have several similarities, they also have significant differences, particularly in terms of security features and the underlying mechanisms they use for authentication. Kerberos is generally preferred due to its stronger security measures, including ticket-based authentication and mutual authentication capabilities, while NTLMv2 is often used for compatibility with legacy systems or in scenarios where Kerberos cannot be utilized.
So this is a good answer. When Kerberos is used and when NTLM is used. Okay, this is also another thing here to have this answer. So let's see. So we can go and see or read this answer.
Kerberos and NTLMv2 are both authentication protocols used in Windows environments, but they have different use cases and strengths. When Kerberos is used, Kerberos is the default authentication protocol in Windows domains and Active Directory environments since Windows 2000. It provides stronger security features compared to NTLMv2, such as mutual authentication, ticket-based authentication, and the use of a trusted third-party key distribution center, KDC. Kerberos is preferred for authentication in modern, distributed systems and open environments with insecure communication links. It is the recommended protocol for authentication in Windows Server 2022, Windows Server 2019, and Windows Server 2016. When NTLMv2 is used, NTLMv2 is used for backward compatibility with older systems and applications that do not support Kerberos. It is used for authentication on standalone systems that are not part of a domain. NTLMv2 is still supported in Windows to maintain compatibility with legacy applications and systems that rely on it for authentication. Organizations may use NTLMv2 if they have important business processes that depend on applications using this protocol and are reluctant to risk breaking them by disabling NTLM. Comparison. While NTLMv2 offers improved security over its predecessor, NTLMv1, it is still considered weaker than Kerberos. Kerberos is preferred for its stronger security features, such as mutual authentication, ticket-based authentication, and the use of a trusted third-party KDC. However, organizations may continue to use NTLMv2 for compatibility reasons or if they have legacy applications that rely on it for authentication. In such cases, it is recommended to minimize the use of NTLMv2 and migrate to Kerberos whenever possible to improve the overall security of the network environment. Share. Rewrite. Sources.
So here we can see the comparison, and we have known what is the LAN manager, and then we can see the setting for the LAN manager or the NTLM version 2. We need to set some setting concerning the NTLM version 2. First of all, we need to set the value of the LAN manager level for the NTLM version 2 to set it to 5. Okay, and we have the current value 3. We will see what are these numbers and what they mean, but we need to change the security setting, or not the security set, change the NTLM version 2 setting, especially the LM level or the LAM manager level from 3 to 5. We have our current value 3, we need to change it to 5. We will see the values and what each value mean, and we need to change something called LSA protection credentials. We need to make it enabled. We will see what this mean exactly, but let me show you also perplexity and the answer, or he will begin explaining what is the LM level and what is LSA protection credentials. But first, let's refer again to the answer. But before that, we need to see something here. Let me see something here. Okay, one thing also, but first let me see here the answer. So what is, I think there is an answer here. Let me see something here. If you go to the library, let me just see one thing here. Okay, I need to go to the library because there is an answer. Again, we need to check. Let me see something here. Just wait for a moment. Control sets. What is LAN manager? Okay, this is the LSA. I think let me go like that and open it. And okay, this is something we need to check, and then let's go to perplexity again. Let me see something here. It is the LSA. Okay, so let's go again to the answer. I need to stop here for a moment for one thing here. Let's see first, or get again to the report. What is LM level? So we have 5 settings, okay, concerning the LLM, so, or the NTLM. We can tell it to, let me show you. So we can, let me get you, or this is the value, or NTLM version 2, the value of 3. So again, let me repeat. We need to change the LM level setting of the NTLM version 2 protocol from 3 to 5. How we can do that? We can do this from the registry, or we can do it from the group policy. Let me show you all how we can do that. If we go to the GP edit, okay, and then we can go to the Windows setting, and then we can go to the security, go to the local policy, and we go to the security, then we go to the network, NTLM. Let me show you LAN manager authentication. Here it is. This is the one. So we have 1, 2, 3, 4, 5, 6. We have, this is number 0, 1, 2, 3, 4, 5. So here my value, it is 3. Okay, okay, here it is send NTLM response. This is an old protocol. It's not secure. We need to have the last one set, send NTLM version 2 response only. Use the protocol, or use NTLM version 2 protocol for authentication, and refuse the old protocols like LM and NTLM. So we need to make sure that the authentication, if we will use the NTLM protocol, we need to use the version 2 and refuse the old LM or LAN manager protocol and the NTLM version 1 protocol. So this we need to change it. Here I was setting my option 2 number 3. This is number 0, 1, 2, 3. So he found this value in my registry or in my group policy. So I need to change it from 3 to 5, the last one. Okay, so this is one we need to do, or we need to check. Okay, we need to do that I think this is in the default domain policy. This is applied to the default domain policy. So this is the first one. We know how we can do it. And now something called LSA protection credentials. What is LSA? Okay, so this is another thing. What is the LSA? Okay, this is a process in the Windows or on the domain controller. So this can be on a normal workstation or on a domain controller. This process is responsible for authenticating the users to the domain or to the local machine. Okay, so this is a process. This is not a protocol. The purpose is the protocol for authenticating the users. NTLM version 2 is the protocol for authenticating the users. These two protocols are used by the LSA to verify that the users have the correct username and password and allow them to access the local machine or the domain. So let's see what is LSA. And by the way, this LSA protection credentials is not enabled. What this option specific does, it secures the LSA. So the LSA is the process that is responsible for authenticating the users. It authenticates the users using the protocols like Kerberos and NTLM. So this process should be protected. If it is hacked, the user can get the stored passwords in the LSA and use it to hack your domain. So first, let's see what is LSA and how we can protect it. So if we go and ask what is LSA, let me see here. I think I have said what is LSA. First of all, the LSA have some settings. Okay, you can play with it and we will see how we can use these setting or these registry keys to secure our LSA. So first of all, the LSA, here is the registry key for the LSA. Okay, what is the LSA? It is Local Security Authority. It is a component of Windows that manages security policies, user authentication, and the storage of sensitive information like password and hashes. It plays an important role in ensuring that users can securely log in to their computers and their credentials are protected. Okay, so this is the LSA. We need to protect it. There is a registry key. If we enable it, it will secure the LSA. What is this registry key? In a specific something called run as PPL. Okay, this is the one. If we enable it, we will secure the LSA. Okay, we will secure the LSA. If we go and ask Perplexity, if we go there, let me go and see something here. Let me close this one. If you go there, what is the LSA protection? Okay, let's see what is the LSA protection. He will give us a complete answer, okay, or an answer concerning what is the LSA and what is the protection of LSA. So here you go. Now we can see this one or read the answer.
LSA protection is a security feature in Windows that helps protect the local security authority LSA process against credential dumping attacks. Here are the key points about LSA protection. What is LSA? The LSA is a critical Windows process responsible for authenticating users, verifying logins, and managing user credentials like passwords and tokens. It stores sensitive information like password hashes in memory, making it a target for attackers trying to steal credentials. What is LSA protection? LSA protection is a built-in security feature introduced in Windows 8.1 and Windows Server 2012 R2 to protect the LSA process. It marks the LSAST-exe process as a protected process light, PPL, preventing non-protected processes from accessing its memory and data. This makes it much harder for attackers to dump credentials using tools like Mimikatz. How to enable LSA protection? LSA protection can be enabled via registry settings or group policy. Set the run as PPL registry value under HKEY under local machine /system /current control set /control /LSA to 1. Configure the setting using a group policy object linked to the target computers. On Windows 11 version 22 H2 and later, LSA protection is automatically enabled by default on new enterprise join devices that meet certain hardware requirements. Benefits of LSA protection: significantly reduces the risk of credential theft by blocking untrusted code injection and memory dumping attacks targeting the LSA process. enhances overall security of Windows authentication by protecting sensitive information like password hashes, complements other security features like Credential Guard that use virtualization-based security to isolate secrets. In summary, LSA protection is a crucial security feature that hardens the Windows authentication process by isolating and protecting the critical LSA subsystem from potential compromise. Enabling it is an important step in securing Windows environments against credential theft attacks.
So here, what is the relationship between LSA and NTLM version 2? This is because we are now discussing the LM or LAN manager setting. While we are talking about LSA, what is the relationship between the NTLM or LM and the LSA? So this is one important question we should ask Perplexity. What is the relationship between these two? And why we should secure the LSA?
There is a close relationship between the Local Security Authority, LSA, and NTLM-v2 in Windows authentication. Role of LSA in NTLM authentication. The LSA is a critical Windows component responsible for authentication, including NTLM. It manages the NTLM authentication process, handling challenges and responses between clients and servers. The LSA stores sensitive information like NTLM password hashes in memory, making it a target for credential dumping attacks. LSA protection against NTLM attacks. To protect the LSA from attacks targeting NTLM credentials, Windows introduced a security feature called LSA protection. LSA protection marks the LSAST-exe process as a protected process light, PPL, preventing non-protected processes from accessing its memory and data. This makes it much harder for attackers to dump NTLM credentials using tools like Mimikatz, enabling NTLM v2 for enhanced security. Enforcing the use of NTLM v2 over the older and weaker NTLM v1 is an important security measure. This is typically done by configuring the network security, LAN manager authentication level, group policy setting, or the corresponding registry key, HKLM/system/current control set /control/LSA/LM compatibility level. Setting the policy to send NTLM v2 response only, level 4, or send NTLM v2 response only. Refuse LM and auditing NTLM usage before enforcement. Before enforcing NTLM v2, it's crucial to audit NTLM usage in the environment to identify any legacy devices or applications that may rely on NTLM v1. Tools like Microsoft's NTLM auditing tool can help analyze NTLM traffic and identify dependencies. Gradually increasing the LM compatibility level while monitoring for any issues is recommended to ensure a smooth transition to NTLM v2. In summary, the LSA plays a central role in NTLM authentication, and protecting it from credential dumping attacks is essential. Enabling LSA protection and enforcing the use of NTLM v2 are important security measures to mitigate the risks associated with NTLM authentication in Windows environments.
So we can see here the direct relationship between the NTLM version 2 and the LSA. So this is why we need to change the LM level through the NTLM configuration, and we need to enable LSA protection credentials. These two features should be enabled. The LM level should be set to 5 and LSA protection should be enabled. Okay, and there is a lot of settings actually that is very important. One of them is everyone includes anonymous. This is also a very important feature. Okay, and this also we have said before that we should not allow anonymous users to take the everyone group permissions, because if this is done, they will be able to dump the accounts and shares, okay, in our network. So these are all related to the LAN manager setting in somehow, because this is related to file sharing and printing and accessing the domain, which is all related to the NTLM version 2 protocol. Again, we can have something. What are the everyone group? What is the permissions of the everyone group? Why it is so important not to let anonymous users take the everyone group permissions. This is one thing also we need to focus on. If we go and ask also Perplexity something here, let me what are the permissions that everyone group take in a domain. So this is, he's saying in some situation they have read access, okay, and they have read access, so they can access or they can list all of the accounts and resources in your domain. And in compare to authenticated users, they have some similarities. So let's first see what is the permissions that everyone group have in a domain. Okay, let's see the answer why it is so important not to put anonymous users in the everyone group. Okay, let's see the answer.
The Everyone group in a domain encompasses all users who can access a Windows system, including both authenticated and unauthenticated users. Here are the key permissions and characteristics associated with the Everyone group. Permissions of the Everyone group. Full access. The Everyone group can be granted full control over shared resources, allowing all users to read, write, modify, and delete files and folders, depending on the specific permissions set on those resources. Read access. In many scenarios, the Everyone group is often configured with read permissions on shared folders to allow broad access to documents and resources within an organization. Security risks. Granting permissions to the Everyone group can pose security risks, as it includes all users, including those who may not have authenticated. This can lead to unauthorized access if not managed carefully. Use and share permissions. The Everyone group is commonly used in share permission settings, especially in environments where resources need to be accessible to all users, such as in departmental shares for HR or IT. Comparison with authenticated users. Inclusivity. The Everyone group includes all users, both authenticated, those who have logged in with valid credentials, and unauthenticated, like the guest account. In contrast, the authenticated users group only includes users who have successfully logged in. Security level. Using the Everyone group can be less secure than using the authenticated users group, as it allows access to all users, including those who may not have valid credentials. The authenticated users group is generally preferred for securing sensitive resources, as it restricts access to only those who have authenticated. Best practices. For security best practices, it is often recommended to limit or remove the Everyone group from access control lists, ACLs, in favor of the authenticated users group, especially for sensitive data or resources. In summary, while the Everyone group can facilitate easy access to resources for all users, it is essential to consider the security implications and potential risks associated with its use. Organizations should evaluate their access control strategies and consider using more restrictive groups, such as authenticated users, to enhance security.
So let's see. So all of NTLM manager setting, you can get all of these settings from a registry key. I will show you all how we can get all of these. Let me show you a screenshot of it. If we go there and open the LSA, so here you go. These are the settings. We can see, for example, here is the run as PPL. This to enable LSA protection. This is the option. Restrict anonymous. Here is the everyone group, or that was talking about in the Department of Defense. If we go there, here is the registry key. Okay, everyone includes anonymous. Here we can see this, everyone include anonymous. This is the one that we should uh, disable. okay, should disable this option. So all of these settings are related, some of them are related to the NTLM version 2 protocol, some of them are related to the LSA or local security access process. So all of these are very, very important settings. We should focus and check it, okay? So all of these are very, very important. Some of them are related to the NTLM version 2. For example, we can see the, let me see the value. So there is the value of the NTLM version 2. We can see the value, or let me see the value here on the NTLM. If we go and check what it is, let's see first level. So let me see the registry key. Okay, so here we are talking about the level, how we can get this from the registry key. I have shown you how we can get the NTLM protocol, or how we can change it to number 5 from 3 to 5 through the group policy. But I think through the registry there is a way. I think it's already stated here. Let me see. I think it was stated. Let me have a look. I think it was saying that NTLM stated to let me see here. It was stated to NTLM. Okay, I think let me have a look. So I think this is the LSA. I think this is the LSA. Yes, correct or not? I think no, this is not. Let me have a look. The NTL, or this is the LSA. Yes, let's see here if we go there. And let me show you the, okay, anyway, I think we can get the registry key for the NTLM. This can be done using the registry key or the group policy. We have seen this, how we can do that, but I think one of these registry keys is related to the LM level or the LAN manager level. We can see the value of 3, maybe one of these. I don't know if it is the authentication package. Maybe this is related to the NTLM, maybe. Anyway, so we can use the group policy to do that without playing with the registry. So here, this is a very, very important test. We are securing our NTLM version 2 protocol. We are securing our LSA process. So by securing both, we are securing the access to our user passwords and accounts. Okay, so this is very, very important. This is a security test to check if you are securing your username and passwords. Okay, so this is very, very good. We can see that. And then the next test is the DC test, which is a very, very famous test. Okay, we have seen this and discussed this before. Is having some errors concerning the replication of the sysvol folder. This is normal because I have one of my domain controllers closed. And then we will stop at the LAN manager, the test of the LAN manager. Let me see if we have anything to discuss here concerning the LAN manager. Okay, the DNS, no. Okay, I think I have seen this. Okay, this is the one. This is let everyone permission apply to anonymous. This is everyone should be disabled. Okay, this is the one. I think I have already seen all of these one. Let me go further. Okay, so we will stop at minute 42. The LAN man server test. We will stop at that. And we will continue on the upcoming video. Hope this video informative to you all, and thank you all for viewing. Thank you so much.